Hello guys, welcome back to our channel. In this class, we are going to learn about graphs. First, let us do the recap of what we did in the first part. In the first part, we learned about motion, motion along straight line, vector and scalar quantity, uniform and non-uniform motion, how to measure the rate of motion, SI unit of speed, and we learned the definition of velocity, displacement, and magnitude. In today's class, as I told, we are going to learn about graphs. So what are graphs? Graphs are used in mathematics as well as in physics. So graphs are the convenient way to represent data. For example, in the telecast of a cricket match, the vertical bar graph shows the run rate of the team. You might have seen this a lot of times. To describe motion of an object, we use line graphs. So graphs are divided into two parts, which is the distance time graph and velocity time graph. First, let us learn about distance time graph. So distance time graph can be also written as dt graph, which is distance time graph. It is the short form for it. This is used when there is a change in position of an object. So time is taken on the x-axis and distance is taken on the y-axis. Here below you can see an empty distance time graph. This is how it looks. Now let us solve an example. So here they have given to solve to plot the given data on a graph, on a distance time graph. So the distance covered is 3 meters and the time taken is 2 seconds. Next 6 meters and 5 seconds. Then again 9 meters 7 seconds. And next it is 12 meters and 10 seconds. So this is an example of non-uniform motion. This is how it looks when you plot the graph. Uh, on the y-axis, it represents distance, which is in meters, and on the x-axis, it represents the time, which is 1 second, 2 seconds. As I told, for the car or any object to cover 3 seconds, 3 meters, it takes 2 seconds. To cover 6 meters, it takes 5 seconds. To cover 9 meters, it takes 7 seconds. And to cover 12 meters, it takes 10 seconds. So this is an example of distance time graph. Moving ahead, let us learn about velocity time graph. So the variation in velocity with time for an object moving in a straight line can be represented by velocity time graph. Here velocity is represented in the y-axis and time is represented in the x-axis. This is an empty table or empty graph of velocity time graph. So now you can see a graph. So the as I told you, the variation in velocity with time for an object moving in a straight line can be represented by a velocity time graph. In this graph, time is represented along the x-axis and the velocity can be represented or is represented along the y-axis. If an object moves at uniform velocity, the height of its velocity time graph will not change with time as shown in the figure. It will be a straight line parallel to the x-axis. The graph shows the velocity time graph for a car moving along the uniform velocity of 40 kilometers per hour. Now, let us calculate the distance, which can be represented as s, moved by the car in the given time. So the formula is s is equal to AC into CD, which is equal to AC is 40 kilometers per hour, as you can see, and CD is T2 minus T1. So the answer you get is 40 into T2 minus T1. So if you take t2 as it can be 3 seconds and t1 as 2 seconds, it becomes 40 into 3 minus 2, which is 40 into 2, which is 80 kilometers per hour. This is just an example. The distance covered is shown as the shaded part in the graph. This was an example of velocity time graph. So the last part of this chapter is circular uniform motion. This is very interesting as well as very easy concept. So when the velocity of an object changes, we say that the object is accelerating. This is a new term which is accelerating. I repeat, when the velocity of an object changes, we say that the object is accelerating. The change in the velocity could be due to the change in its magnitude or the direction of the motion or both. So the movement of an object in a circular path with an equal distance in an equal interval of time, then we call it as circular uniform motion. So the movement of an object in a circular path with an unequal distance in an unequal interval of time, then we call it as, it's easy, right? Circular non-uniform motion. So a few examples of circular motion are moon rotating around the earth, suns and planets, which means planets rotate around the sun, and a person jogging or running around a circular track, etc. So these are some examples of circular uniform motion. So that's it for today's class. Hope you enjoyed the video. If you have not yet subscribed to our channel, please subscribe and like this video if you like it. Thank you.